Hi, everybody. Good morning. This is Mr. Chandler and Mr. Bunny. We're here today to talk to you about land navigation for a number of important reasons, including fun and survival. Bye, Mr. Bunny. You go play. We'll talk to you later. All right. We're going to talk about topographical maps and land navigation. Topographical maps and land navigation for fun and survival. We're also going to relate this back to a prior lesson where we talked about Culps Hill and the Civil War. And here we go. All right, why am I doing this? Why is Mr. Chandler teaching you about this? Well, it's near and dear to my heart. This topic is something I taught in 1999 to a group of Army nurses preparing for deployment. It's the first time I was asked to put a course together and teach something specific that I had learned and was good at. So I enjoy teaching this piece. We're going to have a lot of fun. We get to go outside. As you can tell, I'm outside now, and I enjoy that very much. Special thanks, of course, to the Gettysburg National Military Park, who is assisting us with this lesson, and Instructables.com for a couple of their graphics. Thank you, people. All righty. Now, tomorrow we're going to go out in the wilderness, and hopefully we don't need a nurse. But I did invite her along just in case. Now, why are we using maps instead of our GPS or our Google Maps? Well, a map, a topographical map, doesn't use batteries. It also doesn't require a satellite signal or any other technological assistance. We can do this on our own with just a map and a compass, right? Now let's imagine a scenario where maybe your GPS became disabled or your cell phone was disabled. Say, for instance, you were out hiking on an extended excursion with some friends in the wilderness. While you were out there, you became disoriented for a moment because of a pop-up storm. You ran to seek shelter and decided that while you waited out the storm, that you should get some rest and set out again in the morning as it got dark. Meanwhile, you find out in the morning that you're disoriented and not exactly sure where you were as you rush to shelter, a rock outcropping or a cave, for instance. You also notice that your phone battery has died, or you have no signal. Bad weather can often cause that problem. Not that the Google Maps is going to be all that useful anyway in a wilderness area. Often the map will just be a big green blob that says so-and-so National Military Park or Yellowstone or whatever it is, and it'll be a big green blob, and you can't do anything with that anyway. So, or you're in an airplane and it makes an emergency landing in the Alaskan wilderness while you're on your way out to Nome, which isn't easily accessible on land. You got rough terrain there; it can be very difficult to navigate on foot. You get out of the plane, you've got 1 day worth of water supply for you, so you've got to get out of there, out of danger in a hurry. You have a map because the plane had an aeronautical chart that the pilot was using, and you have a compass. Fortunately, in the other scenario where you got lost, one of your friends did bring a compass along and had a map at the ranger station that they brought. Very smart to do. Topographical maps are widely available. You can download them for free from a number of different web sources, including the national parks and state parks websites if you want to go there and do that. I'm going to put some links on the class website there for you, the classroom, so you can pull down some useful links, including the Instructables.com and the National Military Parks and the National Park Services website, so you can get those maps for free, download them, print them up. You can get them at the ranger stations, and you can buy more detailed and specific purpose maps at the gift shops as well. Now, there's 4 basic steps to using a topographical map. Let's dive into those. While we look at this here, you'll see some familiar area. Again, this is Gettysburg, our town here. We got the Culps Hill, which we talked about from our lesson. We're going to talk about our tools here as you look at this. Our map, we're going to have just paper because our forecast says there's no rain, but I'm going to go ahead and bring at least 1 plastic sleeve along. These are ideal. You can use a Ziploc bag if you want. Open your map to the area you'll be walking around in or exploring, and fold it up so it fits in your sleeve, and zip it up in there nice and tight so it'll stay dry, and you can write with a dry erase marker on the cover. Walmart has these covers as well. If you want to use a professional one, a very nice one there, you can get them for very cheap, along with a compass for about $5. Dry erase markers are helpful. You need a compass and a map for the lesson. All this will be provided thanks to the Park Service. Take a look there at Culps Hill, if you will, on the right-hand side of the map. It's a zoomed-in version of the map on your left. You'll see the Culps Hill has a number of different lines on that map. Let's look closer even. The Culps Hill map has the lookout tower where I gave a video talk from before. You'll see the road there where I also started the lectures from. You'll notice that Culps Hill has a number of lines around it. These are called elevation lines. The lines, as they get closer together, indicate elevation changing quicker or a steep slope. Yeah. All right. And you'll see numbers in some of the elevation lines as well. You'll see 2 number 500s on some bold elevation lines on other hills, indicating the heights of those nearby hills. You can see then how easy it would be, perhaps, to confuse these hills if you had a poor map or poor navigation skills and mistake one for another. This may have been the case historically, where our Confederate reconnaissance troops were infantry and not experienced reconnaissance troops, normally this is done by cavalry, you can see where the infantry tasked with reconnaissance may have made a mistake owing to either poor maps or poor navigation skills. They sent back an intelligence report to someone that there was no Union forces or no Northern forces on the hill that the general wanted to occupy. This may have been wrong, or it may have been an outright lie because these guys did not navigate correctly and were covering their own butts, so they didn't get in trouble when they were back late from their reconnaissance. So you can see how lack of navigation skills can not only be dangerous, but can be embarrassing and can change the course of history, perhaps. Notice, too, on your map, there's going to be a legend at the bottom, which will explain some of these other features, like the road markings there. You'll see a road with the red and white lines marking it. That's a secondary road. You'll see the magnetic north declination line on the map as well. Not on this zoomed-in version, but on the larger version you can see at the website or the ones you'll be given tomorrow. All right, so step one, of course, is to have the right tools. We want to look at some of those features on our tools, the topographical map, our main tool. And you'll want to look at some other things here. At the bottom of the map is our legend. We got to find grid coordinates. It's something we want to learn how to do. To find grid coordinates, you look at the numbers on the border here, along the bottom and along the side. Numbers 16 and 17, for instance, indicate that square there is grid number 16. The one at the far right, the edge of the map there, is grid number 17. And if the map continued on, that other black line there marking the edge of that grid would have a number 18 on it. All right. Looking upward, reading the map upward now, you'll see a number 3 that is marking the bottom of that grid there that's cut off at the top of this section here. So that bottom square there will be grid number 1702. The intersection of Miller's Road and Updike Road on that map fits somewhere in between those numbers, approximately halfway each way. So we'll call that location Miller Road and Updike Road's intersection. Grid location or grid coordinate 1705-0205. Does that make sense? You could also call it 1704 and 0206. Doesn't need to be perfect in this instance. We're not guiding ordnance or aircraft into landing. We're just telling somebody where the intersection of that road is on the map. All right. There are special protractors available to make this more accurate, but they are not necessary for our purposes. What you need to know here is on the map, when you see those grids, like on this section here, you will see 4 different grid boxes represented. There's a cross line in the middle of this map here near the lookout tower. There are 4 different grids there. To be able to identify those grids accurately and the location in them, you'll need to know how to read the grids on the border of the map, the grid marking numbers. All right, excellent. Okay, moving on. Step 3 to using our map and land navigation is to be able to orient your map. To do this, to make the map oriented, is to make it represent accurately the lay of the land around you. So it's facing the same direction. It's oriented to the north line of your compass and the north line of your map match. So that looking out around you, you'll see the terrain accurately represented as it is on the map. That way you can figure out where you're at and figure out where to go from there. Okay, so first thing to do is to lay your map on a flat surface. Maybe you brought a field desk with you, but you probably didn't. Use a rock or the ground. Lay your compass on the map and line the edge of your compass up with the map's magnetic north line. Once you have done this, you will take the map and turn it until the lines of the magnetic north on your map and the compass north-seeking arrow match. So they're both lined up, they're parallel to each other, and they're going in the same direction. Now you can use your compass to find a bearing or direction using the 360-degree numbering system on the edge of the compass there to figure out the direction or bearing to any terrain feature, road, building, grid coordinate, body of water, or health and safety on the map. You can also use that to plan a route. But say you don't know where you're at. In our first scenario, you were lost, or your plane crashed in an area that you were unfamiliar with. You'll need to be able to find yourself on the map. Some people will call this triangulation. That's cute, but it's actually just called resectioning. You'll want to resection to find your location on the map. Now that you have your map oriented from step 3, you need to find landmarks. The map is laid out accurately to represent what the land looks like. Everything is oriented along the same direction lines, so you will look around, find a landmark. Start on your left. Once you find a landmark, something prominent, telephone pole, tree, a body of water, a hill, something prominent that matches up the terrain features on your map, road, anything. Take your compass and put it on the map with the edge of the compass running through the center of that terrain feature, and then just draw a line back towards yourself. On the right-hand side, repeat this process for a landmark on your right. Take your compass, place it on the map Line that line up through the center of your terrain feature you've identified on your right, draw it back through, the line back through towards you, and you will see an X on your map appear there. This is your location. This is probably the only time in life where an X will mark the spot. All right, that's important. Why? Well, using that information of where you're at on the map, you can now plan a route to safety. You can use your brain there to, even if you can't see, for instance, a road behind a hill, you can know where it is because you know where you're at on your map, and you can find a direction or bearing to it, and you can get to that road. You can also plan the easiest route over that hill or around that hill, avoiding extremely steep and arduous and difficult terrain and finding an easier route, which may mean not going in a straight line, but going in a certain circle. You can draw that on your plastic sheet with your dry erase marker and help your friends find their way out. Using the skills at finding your grid coordinate, you can figure out where you're at on that map. If you had to leave a wounded comrade there behind, somebody on a stretcher with a splint on or a bad leg or is unconscious and wrapped in a blanket to keep warm, you can mark on your map, know the grid coordinates to report to the police or rangers when you get home to safety. You can tell them exactly where you left your friends so they can find them. Very important life-saving skill. Impress your friends at parties and on hikes. Just real quick, just want to say thank you for paying attention to this. I will be sending out email with team assignments and the links to the different resources. Remember, tomorrow we will have maps and compasses provided, as well as the plastic sheet cover, at least one. You will want to bring water and maybe some deep woods off and proper shoes. It's tick season, and we're the tick capital of the universe, so make sure you have at least 20% DEET. I think it's 25 for the deep woods off to keep the ticks off. I will have some in case you forget. And if there are any questions, you shoot me an email real quick, and I'll get right back to you before you know it. I'll be online till at least 10 o'clock tonight, trying to figure out where the bunny got to.